Swayam Prabha. Digital India. Educated India.
Welcome to Structural Dynamics class. In this class, we will study about numerical methods based on variation of acceleration. So, a special application in that we study about Newmark's method. As you have seen in the previous class, we had discussed about central difference method. So, in central difference method, what we were doing is like we are calculating at displacements at each time instant, and we converted acceleration and velocities in terms of displacements, given displacements. Okay. So, in Newmark's method, what we do is forcing function, which is in the form of acceleration or force, we will in between two time instants, we will calculate either a linear variation in between the two time instants or average variation in between the two time instants. So, those two topics we will discuss in this class. So, Newmark has developed a family of time stepping methods based on following two equations. These two equations have been developed, that is velocity at I plus 1 the time instant is dependent on velocity at that time instant ith time instant plus 1 minus gamma into delta t into acceleration at the time instant plus again gamma delta t u double dot I plus 1. Response acceleration is needed. So, this is the equation and the displacement equation. So, these two equations have been developed for time stepping methods. So, these parameters beta and gamma defines the variation of acceleration over time step. So, usual values of gamma are 1 by 2 and beta value can range from 1 by 6 to 1 by 4. Depending on cases, we will discuss this, we will use this beta value. Now, these are basic equations as shown you in the earlier slide. Now, if delta ui is ui plus 1 minus ui and delta ui dot, that is a increment in displacement, is equal to displacement at time ti plus 1 minus displacement at time ti. Velocity also, increment in velocity is velocity at I plus 1th time instant minus velocity at ith time instant. Acceleration increment is I plus 1 time instant minus acceleration at ith time instant, and delta force, that is increment, force increment is force at I plus 1 time instant minus force at I. Now, substituting it in the A, so and rewriting the equation. So, what we get is this for velocity term and this for the acceleration term. So, first and second. So, if we substitute these things in the above equation, we get delta ui, okay, delta t u double dot I plus gamma delta t u double dot, and similarly delta u, increment in the displacement, increment in the velocity. Now, basic equation is mu double dot plus cu dot plus ku is equal to p. We are rewriting that equation in the form of incremental acceleration, incremental velocity and incremental displacement is equal to incremental force. So, converting this equation into this type, k cap delta u by delta I delta p cap. So, whereas k cap is k plus gamma by beta delta t into c, gamma by beta delta t square into m, and then delta pi cap is given in this form. Now, let us discuss the average acceleration method. So, what is average acceleration? T is equal to Ti, this is the acceleration value, that is u double dot I is acceleration value. At T is equal to Ti plus 1, this is u double dot I, sorry, u double dot I is here, u double dot I plus 1 is here, u double dot I is here. So, the average acceleration means you can see at any time instant in between these two Ti and Ti plus 1, u double dot tau is equal to half, that is average of acceleration at I plus 1th time instant plus acceleration at ith time instant, as you can see here, half of that. So, average of that. Then u dot tau is equal to, how do we get that? So, you integrate it, you will get it. So, u dot I, you integrate it, and at u velocity at I plus 1th time instant is u dot I plus delta t by 2 u double dot I plus 1 plus u double dot I. So, this is how we get displacement value, and displacement tau, sorry, velocity value, earlier one, and displacement value you can get from this equation, again integrating it once and then substituting this time instant. So, this is acceleration term, this is velocity term, and this is displacement term. We make use of these things in the further equations. And then linear acceleration method. In linear acceleration method, as you can see, acceleration at this time instant ti, acceleration at next time instant ti plus 1 are known to us. Then how do we define acceleration in between? So, in between means what? So, ith term acceleration will remain, as you can see in between this we need this value. So, that value can be found out by u double dot I plus 1 minus u double dot I, this value, divided by delta t into whatever time is there. So, this is from similar triangles we can get it. Okay. And then again if you differentiate it, you get velocity term. So, velocity term you represent in terms of I, and displacement term again if you double differentiate it, then you get again displacement term at this time instant. So, we need these 3. So, linear acceleration method, angular acceleration we found out. So, now let us discuss step by step procedure for this one. So, first of all we need to fix gamma value and beta value. Okay. So, for average acceleration method, gamma value is half, beta value is 1 by 4. For linear acceleration method, gamma value is half, beta value is 1 by 6. So, these methods are very sensitive to these beta values. So, for initial calculation we need first initial acceleration, which we have earlier discussed. So, this is coming from the equation of motion, that is mu double dot 0 at a time 0 time instant cu dot 0 plus ku 0 is equal to p 0. So, from that we get initial acceleration. Now, select delta t and then find out k cap. Okay, k cap is equal to k known stiffness of the system plus gamma is known here, and damping value is known, beta value is known, and time step is known. So, 1 by beta into delta t square into m. So, all these ones. So, this value, this is a constant value k cap, and then we find out a and b. So, a is dependent on like all these parameters, mass and damping parameter, gamma and beta value, and b also same thing, mass and damping parameter, gamma and beta, and the time instant. So, a, b for values we found out. Then after that calculation for each time step. So, calculation for each time step is delta pi is equal to delta pi cap is equal to delta pi plus a u dot plus b u dot, it is I only, okay, b u double dot. So, we know what is this a b values. So, you substitute that a b values, and then delta ui we get is equal to delta pi cap by k cap. Remember this one, delta p is calculated at every time instant, whereas k is a constant value which is fixed. So, it will not change in the analysis. Then similarly we find out velocity increment, and then we find out acceleration increment. So, like this we populate it. So, we want to find out displacement. So, displacement at u1 is equal to displacement at 0 plus displacement delta u at 0. So, like this, velocity ui1 is equal to velocity at 1 plus delta velocity at 1. Acceleration at 1 is equal to acceleration at 0, acceleration at 0 plus delta acceleration at 0. So, that is how we will get. So, from the current displacement and the difference in displacement, we get the next step displacement. Difference in the current velocity, we get the next step velocity. Current acceleration and difference in current acceleration, we get an acceleration of the next step. So, that is how we populate the table. So, in this one we should remember one thing is stability condition. So, usually delta t usually is small by Tn. Tn is the natural period of the system. So, how do we get this Tn? Tn is equal to 2 pi by omega n, and we get omega n in natural frequency under root k by m. So, if we get this one, delta t by Tm should be less than 1 by pi under root 2 into 1 by under root gamma minus 2 beta. So, this is a stability condition. So, usually this is met, but if we are not getting the proper results, we can check this condition whether it is met or not. As I discussed in the previous class, there are three important criteria for numerical methods. One is convergence. Okay, solution should converge to exact solution as the time step decreases. The second one is convergence. Stability is the second one. Numerical error should be rounded off, otherwise it will blow up. So, that is the second one, and third one is accuracy. So, convergence, stability and accuracy, these three conditions for the numerical method. So, in summary, what we have discussed is the Newmark's method. So, Newmark has given two equations, one equation for velocity and equation for acceleration, and then these things will be used as a numerical method for finding out acceleration, velocity and displacement at each time step.